Alright, next on the bench is the little baby of the 50 series. It's a Pioneer SX450, and I've been really wanting to go over one of these once because everything I hear about them is they're supposed to sound every bit as good as the 1050s and the 850s and so forth, but just be lower wattage. It's only rated at 15 watts per channel, all the same quality, all the same high end of build quality as the bigger units, and really nice weighted tuning knob. I haven't really tried this thing out. I don't even know if it plays. I don't know anything. We're just going to test it out and go through it. I have my new dummy load mounted up on the bench. So I have a MP3 player down here just to give me an output for these things. And then of course I have the dummy load set up. So in my oscilloscope, and there's the wires going into it. So we have everything ready to go. So let's get this connected up and see what happens. Alright, we're all plugged in, and let's turn it on. Okay, so we have power, and let's just take a voltmeter here real quick, and let's see if there's any DC on the speaker terminals. Make sure it's safe to connect up. Anytime you come up with a new stereo, a new receiver like this, you want to kind of make sure there's no shorts or anything like that. So let's see, the A speakers are right here, and we have about 300 millivolts here. About 300 millivolts here. So that tells me that the DC balance is a wee little bit off, but these cheap units usually don't have balance, so you kind of have to deal with that. But 300 millivolts is not going to hurt the speaker, although it does need adjusted if we can do it. So it's safe to hook up. So let's get some speakers on it and see if it plays. Alright, I got some speakers hooked up. Let's see if we make any sound. Yep, I'm not hearing anything. Nope. Totally dead. Got our speakers connected, and we have absolutely no sound. AM, no FM. Let's see if we go to AM, no deflection of the signal meter. So I would say right off the bat we got a power supply problem. So let's crack this open and see what we have. Well, I can definitely say we are infested with dust bunnies here. Wow. So I guess the first thing that needs to happen is we probably need to clean this thing out. It is really a mess. So I'm going to try to brush a little bit of this out and vacuum it a little bit and get some of this mess out of here, and then try to address wow, this thing has 5 fuses in it for a 15 watt amplifier. That's a lot of protection. So we're going to go through and check the fuses, check the power supplies, find out why it's not coming up. I'm also very impressed with the large transformer they have in this tiny little 15 watt amp. Up here, I don't know if this is a leaky capacitor or if that's just gunk. Definitely got our work cut out for us on this one. So, alright, so I'm going to start cleaning up. I'm going to get this thing cleaned and get it set up to test the power supplies, and then we'll be back. Alright, got some of the dust out of here and looked through it, and these two 4 amp fuses coming right off the transformer were blown. I statically measured the transistors, the diodes, this transistor, a few things statically measured across the outputs. I did not see any shorts. That doesn't mean there isn't one. We could have a capacitor leaking or something, but let's turn it back on and see if it blows the fuses. We're going to do this right here on camera. All right. Actually, I'm going to put this in my load limiter because we want to make sure. There. Okay. Let's turn it on. Hey. Okay. And 1 a.m. I'm still not getting any deflection of anything. So I don't have schematics printed out yet for this, but I think the next order of business is that I probably need to do that. I'm just going to do a quick little check to see if we get anything out of these power fuses here. Nothing. 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 So, as we can see, we're still not getting any power. So we're going to have to, and I statically measured the transformer, but I should probably check and see if we have AC coming out of it. Sure enough, 37 volts. So we definitely have AC coming out of the transformer. Let me get this in the shot a little closer. So if I go from this fuse to this fuse, I have 37 volts AC. Probably should flip this up and see if I get anything across the main capacitors for DC. So let's take a look at that. If I can do this without everything shorting out. Okay. Let's turn this on. Put the meter in a little bit. Okay. And the big capacitors are up here. Let's see here. I think they're here and here. I'm going to check those. Nothing there. Make sure I'm on them. I still don't think I'm on them. I think maybe they're back here. I can't tell. Nothing on those two. And nothing there. I'm only getting 1 volt. And those screws there, I think, are holding down, yep, the strain reliefs for the big capacitors. So I definitely, I'm in the general area. Let's see if I can get this shine back here. I am not getting any voltage on anything. Let's see. If I go right about there. Yeah, this is, there they are, right there and there. And if I go from here to here, there we go. Negative 23 volts. Okay, so I got power there. How about this one? And that's positive 23. 23, negative 23. So we do have basic power to the amp. Let's see if that's referenced to chassis ground. So let's go on the chassis and measure. Measure. Yep. So that is. So I should be able to come over here now and see something on these transistors here. And I do. I'm pretty much seeing the same thing. Okay, nothing there. That side's, yeah, there's some. Nothing on the output though. So I don't know. Compare our channels here. Well, it matches. So until we get another look at this, at least we know we have your DC rail, but something's shutting it down. So we need to print schematics at this point in time. At least we got something here to show for it, but I think we still have power supply problems down the road. So I'm going to print out some schematics and then come back to this here in a little bit. All right. Okay. I've got some schematics printed out, and the first thing I'm going to look at is my 36.5 volts right down here on pin 8 to pin 7. Okay, I can also pick it up on pin 10. So let's see, 7 and 8 right there, 7 and 8. Let's go. And by the looks of it, 33.9 volts. So we have on 36.5, I got 34. 34 out of 36.5. So it's off by a little bit, but we do have power. So let's go to pin 6 to pin 7. And that should be my 13.7, and it's 13.5. That's almost right on. Okay, so we have our low voltage supplies, and there really is no test point for the DC rails. However, if I look up here, we can see that it's going into the collectors of the transistors. So, well, it's going into the collector of the NPNs here. Well, they're all NPNs. Okay. So we're going into the emitter on one side and the collector on the other side with our plus and minus. So Q212 and 214. So 212 and 211 are both going into the collectors. So if I check 211 and 212, which they're not really marked on the board, but we can check it possibly like this. No. How about that one? There we go. So we got it there. Not getting good contact, but there. So it is there. And you know what? Let's try a different probe here. It's easier to get to. Okay. So right here, 26. Here, so the two inside ones. 26, and then we need to get on the emitters of the other ones, should be the minus 26. So let's see here. Minus 26 there, minus 26 there, minus 26, okay. And I'm already smelling some electrons in here. So let's see, what is getting hot? Regulator's not hot. None of the current limiting resistors are hot. I should probably unplug this because that's not a very good example for me to set in front of you all. Couple of these little power resistors here in the power supply are warm, but they're not like they should be smelling hot. None of the capacitors are hot. None of the transistors are hot. None of the drivers are hot. Strange, because we are not getting an output from this amplifier. So let's hook up our dummy load and come back, put our scope on, and let's just try to feed some different signals in here and kind of poke around and see if we can find where we're losing it. Okay, so I've connected a signal generator and I've gone to the auxiliary input. I still haven't cleaned any controls or anything, but by the looks of it, both channels are out, although I do have voltage everywhere. At least I have my power supplies. So we're going to turn this thing on, take a look at the scope, which I will try to get up in the corner of the screen here while we're poking around. You can see it right here's my scope. Okay, see if I can get a little bit wider. There we go. And we're going to see if there's anything coming out. Here we go. Helps to plug it in. Okay. Alright. So let's move this down to 1 volt per division. See, as you can see, there's almost nothing at all coming out of this. So there is absolutely no signal. So I'm feeding a signal in and getting nothing out. So we need to start and work our way back. So now I'm probably going to connect up a probe to the oscilloscope, and we're going to go through the stages and just see where we're picking it up. Now it is kind of strange that both channels are equally out. So in other words, I have no signal from either channel. So it has to be something common. So I'm still thinking in the line of we have a power problem. So we're just going to have to look and see what's going on. Let me just try one more thing here. I'm going into, let's see if there's any kind of output at all. Yeah, I guess there's a wee little bit of signal. Almost nothing at all, and it's very distorted with the power turned, the volume turned all the way up. I have almost nothing. So, okay. So let's see what's going on here. Let me get this rearranged and we'll try it again. Okay, so I have my scope hooked up, and I have what is not, it's a modified version of a probe here, and really all it is I took the ground lead and extended it so I have more room to move around. Now I never recommend to take this ground lead and extend it like this on a probe that you're going to use for RF. You need those probe, the actual probe length is short for a reason, so that it doesn't mess up your attenuate your signal. But for times that you're working around inside of a machine like this, where you have to ground it and move around, you really, when you're tethered to a short cord like this for line frequency thing, you know, audio frequency, it really makes it tough. So I did this to an old probe. You can see it's got tape on it and everything, but it makes it a lot easier to move around in here. Again, I wouldn't recommend this to a good probe unless you have the removable grounds that you can plug and unplug, and you can just make a longer one. But it's fine for what we're doing. So anyhow, looking at this, we want to get on test points 9, or binding post 9 and 10. And if we go down and look in here, 9 and 10 is right here along this little strip down here. Okay, I don't know if you could see that. So let's start out by going on pin 9. Alright, and turn our power on. Now again, this should be before the volume control, so I should get a signal when I turn this on, and I do. However, if you look, this signal is actually floating at, oh my goodness, about 16, 18 volts, okay, DC. So if we go into our input menu and we change the coupling to AC coupling, and then we move our volts way down, there should be, at this point in time, we should have some sort of an output or some sort of a signal there. And as you can see, we do not. So basically that pin is just floating high right now. And the other pin would be pin 11, which is the other channel. So 9 and 11, with 10 being the ground. And as you can see, there is absolutely nothing on there. So whatever the problem is, it's prior to this, okay? Now, we can also look at C109 and C110, which are these two tantalum capacitors, which I don't like them. But basically, this is looking at the bottom foil side of the board, not the top side that we're working on. And if you look here, there's the pins, and C109 and 110 are right here and here. So they're right next to these pins. And you can kind of see them if I move this up. I'll show you. They're way down in there. Okay. So let's see if we can zoom in a little bit to see where we're looking at. Okay. So see those two little blue tantalums there? Those are the ones. That's 109 and 110. So what I'm going to do is I'm going to try to inject a signal on the other side of them. I may just get something in touch with my finger just to see if we can induce some noise there and see if at least the amplifier is working at that point. Okay, so again, that's going to be before the volume control. Actually, what I may do is I may move over here to this 201 and 219 and 202 and 220 and get on the other side of the volume control, because we're not worried about that right now, and try to get some kind of a signal here to see if this amplifier section is even working. So let's do that next. Okay, so there's a little jumper wire here, this little green wire, as you can see it, and that takes the signal from the preamp, from our volume and balance controls, and kind of jumps them to the other end of the board here, and to where the power amplifier section is. So if I touch those two wires, that's the same as touching these 2 points right here and here, and what I should see is I should see these deflect. Okay, so let's do that. So I'm touching the inputs of the two wires. There's number one, and you can see I'm getting a signal. Okay, when I touch ground, it goes down. See there? So the amplifier is actually working. I'm at 1 volt per division, so I'm getting a little, I'm just basically getting the hum from my body. And you can see once again, both channels are working symmetrically. So I'm pretty convinced that the amplifier is fine. Okay, now we could get crazy with signal generators and isolation capacitors and all that. I'm not going to mess with that. We know it works. So we know our problem is in the preamp section, and we know that it's probably coming from right at the beginning there. So what we can do is we can touch on the other side of that capacitor, which is right here, 109, all right? So we can go on the negative side of 109, and we should be able to see some kind of signal. All right, so let's do that. And you can see, turn the volume up. Oh, now we're getting something. That's really strange. It was totally dead before. And now we're getting, well, I'm sorry, I'm on times 1. No, we were getting nothing. You saw it. So just poking around in there, it started to work. You can see I have a signal in there now when I didn't have it before. Alright, so let's see. Let's change our voltage. Go to 5 per. And I should, yeah, look at that. Getting all kinds of output. Starting to clip. So they're not symmetrical. And that could have to do, that's just, I think, yeah, dirty potentiometer there. I think we could fix that just by cleaning it. But as you could see, it has decided it wants to start working. So what that means is one of two things is happening. Probably you either have a capacitor that's leaking and it reformed. Oh, we just lost one there. See it? We just lost a channel. And the other one's getting all shaky now. It's shaky probably because the sync of the scope is on channel 1. So we obviously have a component failing. It's probably going to be a transistor or maybe a leaky capacitor, but my guess is going to be we have a bad transistor. Okay, so next, these are really hard to troubleshoot, these sorts of things, because we need to find out where we are losing the signal. And again, when we were looking at this one input over here, it was sitting at positive voltage. Now what I would like to do is jump over to here real quick. Okay, and move this down and see if our just see for the heck of it if our DC voltage has come back. Yep, see, it's still sitting high. You can see that, both channels. So we know that probably it's supposed to be floating high because the one channel is still working and it still has a DC level on it. Okay, so that's probably that isolation capacitor is what's blocking that 0.33 microfarad tantalum. Okay, and this is how we learn as we move along. So with that in mind, I'm going to look at both of these channels now on AC coupling, and I'm going to see, and you can see right there I have a signal, and if I move to the other channel I have a signal. Okay, and of course the volume control is adjusting it, which that's kind of strange because if you look, I'm looking at pin 9 and 11, and if you look here, these pots are on the opposite side of that and should really have nothing to do with any of that. Now, what does that mean? Well, that could mean that one of these capacitors is shorted, because tantalums have a habit of shorting, so we could have a problem with that. You can see if I turn the balance control, even the balance control affects it. So I'm venturing a guess that this one of these tantalums is problematic. So let's tip off the probe and let's look on both sides of the tantalum and see if our DC voltage goes away when we get on the positive side of that tantalum. So nope, it's still there, and it's still there. And you can see I'm a 1 volt per division, so we're off the charts. So again, we're sitting at about 15, 16 volts on both of those capacitors, and it seems to be the same whether we're on one side of the cap or the other. It doesn't, well, no, okay. I take that back. Okay, so that cap is good. Okay, all I have is signal. If I go to this other one, it's good. So we don't have a shorted capacitor, I'm sorry. So when I look at this side of the capacitors, I have the voltage. On this side, I do not. Okay? So we know that this is working. All right? We also know that we connect our hook back up. If I go to this, I've got it. And if I go to pin 4 of the tuner board, I've got it. And if I go back to AC coupling again, and I change my voltage way down, okay, again we see the signal there. Alright, and I think we just found another mistake that I made. These pots are not the volume and balance, these are bass and treble, which is why it's not affecting it. So that's good. Just looking at the board here, here's our volume pot, here's our tuner board. So the volume is on this side, and bass and treble are on this side. So those are the bass and trebles that were on that board, which makes sense now. Okay, so that's why the volume does affect it. So we get on this channel, and we go to this channel, and I have my signal. If I look at my outputs coming out of the amp again, look at that. It's back. So for some reason our signal's intermittently coming and going here. So now what do we have? Do we have a failing component? So the next time it fails, I think what we're going to have to do is get some freeze spray and go around to some of these pots or some of these transistors down here and see if one of them isn't causing all the problem. The other thing I noticed is the amplitude of the one channel is a little bit smaller than the other. It always seems to be. And I don't know if it's the balance pot, which I haven't cleaned yet and it is noisy, or if it's related to why the channel is cutting out. So let's let this cook a little bit and see if I can get it to fail again. Nothing seems to be warm or anything like that. And then I'll come back. Who knows, when we're done, we might come all around full circle and find out that all we needed in the first place was to just recap the whole thing, and it's fine. Because we may have some voltages that are going crazy because we have a capacitor that's leaking and causing voltages on the transistors. So in order to do that, we're going to have to check voltages on all these transistors until we poke around and find the problem. And if the transistor isn't acting up, you won't see it. So we're just going to have to be patient and see what happens. So as soon as I get something to report, I'll be back. Alright, so here's what we found so far. I'm running this thing at about 8 watts per channel right now, close to it. And when I first had this going at about 3 watts per channel, this heatsink was getting really warm. These two transistors were getting warm, these two inner ones. And everything now has seemed to cool down a little bit. I mean, it's warm. I'm running it at half its full rated power of 15 watts per channel. So this is going to run warm, but it's not roasting hot like it was. And I think really what's happening is there are some bad capacitors in here, and some of them have reformed a little bit and are behaving a little more. The other thing I found was the loudness switch had dirty contacts in it. Now, these push-on, push-off slider switches can be a challenge to clean, to get inside. So what I did was, there's a craft store called Pat Catan's. They have all kind of different craft items, sewing items, all kind of things. And one of the little things they sell is a thing called a pin vise. And what you do is you take and put a little drill bit in this pin vise, and you just use your fingers to drill holes in plastic and things. Okay, it's used for crafts, but it's really good for what I use it for, and that is, if you look at these switches down in here, you can see this one here, I drilled a little hole in it. See if I can get into it. See there? See the little hole I drilled? And you can do it with this pin vise very, very, very carefully and slowly. And as you're making the dust, you know, the little spiral plastic that comes out of the phenolic, you clean that off before you pierce all the way through. And you just keep cleaning, cleaning, cleaning. Go real slow and take your time. You don't want any dust at all to get in there. And then when you're done, you have that little access hole. You can then get some deoxit, some of this deoxit D100, which is just deoxit. There's no cleaning. It's just the 100% solution. Or you can use deoxit D5, which is the 5%, and then it has some cleaning agent, which is pretty much just mineral spirits. And spray it in that hole, work the control probably 50 or 100 times, and it'll clean that control. When you're done, if you're concerned about any dust or dirt getting in there, you can clean it off really well. Just get some alcohol or naphtha or something on a little cloth like this and clean it really well, and then you can just take a little piece of black tape or something and stick over the hole to cover it. And then if you ever need to get in there and spray it again down the road, it's going to be easy the next time. So that's just a little tip. If you try to take those covers off, those little contacts can pop out and you'll never get it back together. And don't ask me how I know that, but just a little bit of experience there, a way to clean those. So we're going to go through it now. I'm going to keep testing. I'm going to make sure this thing's running somewhat stable, and then we're going to go through the process of recapping it. Again, some of this gunk up here, I don't know if it's leaking or if it's just glue from the board, because sometimes they glue these capacitors in when they're wave soldering them so they don't fall out when they're soldering them. I don't know, but all I know is this is a mid-1970s machine, and it's all original. So you have capacitors that are pushing 40 years old, and if they haven't failed now, once you start really using this thing, they're going to fail. So to me, the best thing to do is give this a good burn test, make sure everything's going to be functional, and then go ahead and recap it. I think that's also going to solve our problem of the slight imbalance between the two channels. If you look, you can see that this channel just is a little weaker than this one, and if you turn the power up all the way, you'll see that the higher channel goes into clipping just a little bit before the lower channel, and that's normal. So what that tells me is there's probably a coupling capacitor somewhere that's leaking, and it's not allowing the signal to come through. It's attenuating the signal a little bit, possibly. So, like I said, we got led down a rabbit hole a little bit here looking at that DC, but as it turns out, that's normal. Doesn't really say anywhere here about it, but from what I can see, that's normal. Okay, that's probably why this isolation capacitor is in here to begin with, up here in the beginning. If I can see there, right there. So, voltage here, no voltage here, that's normal. These tantalum capacitors, they're very stable as far as their capacitance is concerned, but when they fail, they really fail. They go dead short. So I'm always on the fence on some systems whether I want to replace them or not. If they're used in a place where, you know, you have voltage on them that's a considerable amount, usually I'll just go ahead and replace them with really good modern capacitors, non-polarized ones, and they'll last forever. They're just as accurate in tolerance as the tantalums. That's the real reason they used tantalums, was because of their accuracy. They didn't drift, they didn't go bad. The only thing they did though is when they failed, they dead shorted and caused other problems. So that's where we're at. You can see that one right there that's all cruddy. We're going to go through and recap this thing, and I'll be back once I do that. Alright, so this was bothering me a little bit about that stray voltage on the other side of the input capacitors. If you remember, we were seeing, you know, about 15, 16 volts, 17 volts, something like that on the inputs here. So I went to the other schematic just out of curiosity, and I kind of checked here. Pins 3 and 4 were the wires, you know, where it comes out of this board and goes to the other board, the powering up board. And if you look at these two little transistors here, you have your B plus voltage of about 36.5 volts coming in here, and going through the one, if we look here, it goes through the 1K resistor and through the 82K and then down into the 680, okay? And it also goes through a 220K and 56K into the base. So you're partially turning this transistor on, so it's pretty much running in class A. And because of that, you're turning this transistor on partially, but you're also leaving voltage here on this collector, okay? So if you look at the output, you're coming right off the collector here. So you're going to get close to half of the voltage in there, okay, when it's designed for class A. So really, you take your 36 volts and cut that in half, and we were a little under 36. We were more around 34. Half of 34 is 17. So that was your 17 volts that you were seeing sitting on there. So that's perfectly normal. And that capacitor was just isolating it. So, you know, this is very typical of these designs. The later designs, the next ones that came after this, were called DC amplifiers. And a lot of people believe the word DC is DC, direct current. But really what that meant was direct coupled. And with those types of amplifiers, they were designed in such a way that you didn't have a lot of coupling capacitors isolating it. Those voltages were, you'd come straight out of here and go into the next stage, and they were all designed in such a way that that floating voltage didn't really matter. It would drive the next input stage. So a lot different design. We'll get into that later. I think I do have a DC amplifier here, a Kenwood, that's be coming up on the bench here in a little bit. But anyhow, that's what that's for. So that's perfectly normal. Again, I think our amp is working, but I do think we have some capacitors. Seems to be all it ever is anymore. Capacitors and leaky transistors. But that's the name of the game with this 1970s vintage stuff. The caps back then just weren't the same quality. Well, they were good quality, you might as well say. That's 40 years ago, and they're still working today, so I guess you can't really complain. But anyhow, I'm going to start recapping this, and just thought I'd give you a little update of what I found. So the other thing I noticed, and I'm thinking of doing something about, is if you look in the schematic right here, and this right here, there's your outputs on the heatsink. That's the dashed line. There's your driver, there's your pre-driver, okay? And right in between here, this is how you bias the thing. They're actually using these 3 diodes, which is actually one little component that has 3 diodes in it to give you your voltage drop of 2 volts or 2.5 volts, whatever. And basically, normally they would have a pot in here that you could adjust the bias of this. But the way they're handling it is they're actually having you, if you look in here, they have this little jumper, and that's this yellow jumper right here, and one for the other channel. What they're doing is they just basically have you measure the bias voltage in the adjustment section. If it's within a certain tolerance, you leave it alone. If it's outside of that tolerance, you cut the jumper, and that's really it. It is what it is. You don't have any balance adjustment, and you don't really have any finite bias adjustment. So I may modify this a little bit by taking this out, taking out this 18 ohm resistor, and perhaps putting a pot in there, a very low resistance pot, maybe like a 47 ohm or something like that, so that we can get a little better adjustment of our bias. We're still not going to get a balance. The only way you're going to get bias balance is by having perfectly matched transistors. And I'm assuming these are pretty well matched. When I look at the DC offset on these, they're not perfect. You got about 300 millivolts, and that's a little higher than I like floating on there. I like it to be under 100 millivolts, but not much we can do about that other than transistor matching. But anyhow, that's another modification I may make. So we've got a little bit more to report, then I'll be back. Alright, where we are now is the right channel is definitely out. It is cutting out. And looking at the voltages, they're all good. Power supplies are good. Everything is good. It seems to be on this side, so what I'm going to do is I'm going to lift the wires that connect right and left channel from this board over to the power amp board. I'm going to feed a signal through an isolation capacitor into each channel and just see if everything's good on this end when this end is not working. So that's where we're at now. So as soon as I do that, we'll be back. Okay, first thing that we found here, making some progress, is these two capacitors. One of them that I replaced on the one channel is defective. And it's strange because, and I can't demonstrate it right now because I've just disconnected some of this, but when you turn the volume on, even when it's playing, it sounds like the tweeter's out. There's no high. And if I take the capacitor and just kind of wiggle it with my finger a little bit, the highs come in and out. So probably defective capacitor. So what I'm going to do is I'm going to replace those electrolytics with these poly capacitors right here. And they're much more stable, much better for sound. I'll put those in for one thing. The other thing is, it is a very baffling problem. One channel will go out, then the other channel will go out. Randomly. They just cut in and out. And what I think's going on is clear up here in the front end, or the end of this preamp, I think we're having a problem in here somewhere. So what I'm going to do is replace those capacitors to rule out those issues. Then we're going to go and connect some music up to this. And we're going to kind of follow through here some of these voltages and see what's going on. We may have a resistor that's actually bad or something like that. So that's where we're going next. Okay, so I am connecting directly from the RCAs out of my player directly into the power amp, and if I control the volume from the MP3 player, as you can hear, both channels are playing perfectly. I've got it narrowed down to here, into the preamp section, and when I look at the collector side of each channel, one channel sitting at idle with volume all the way down, which is grounding the bass, area, I'm getting, as you can see, about 17.5 volts. And if I move over to my other channel, 16.8. There's a pretty good difference there in the idle voltage between them. And if I look at my base and my collectors, none of them really match. And emitters, they don't match. So these transistors, at least one of them is leaky, if not both. And you know, spot checking some of the components, there's really not a whole lot going around here. Capacitors have been replaced. So really all we have here, you have these blocking caps right here from your volume pot. And the volume pot's all the way down, which is taking this 1K to ground on each side. So really, it's saying I should only have 2.7 volts sitting idle at the base. And I should have about 9.1 sitting there at any given time. Unless that's a typo. Could be 19.1, I don't know. Either way, it's wrong. I do not have the correct voltage on there. And they don't match between the two channels. And that's with no signal, nothing connected. So, and volume all the way down. So we know that just in this small area here, I mean, that's where it is. So I am inclined at this point in time to replace these transistors, which in these old Pioneers, the little transistors are the worst. I'd say at least half of the time when I do one of these amps from this era, at least one of those little transistors is bad. I think if you go back and watch my video on the SA7500, we had one of those little transistors. One or two of them was bad in that one. I think in the SX1050 had a problem in that one. Strangely enough, the Kenwoods and some of the other ones out there, not quite as often do you see that problem. You'll have some problems in the outputs once in a while, but not the little transistors near as much. But high failure items on these. So I'm going to go ahead and shotgun those, replace those two transistors. While I'm at it, I'm going to more carefully measure the resistance of all the resistors, make sure there's none of those are bad, and then and make sure also that none of them are bad mechanically, because resistors can mechanically go bad, where they kind of lose their connection to the carbon inside. So I'm going to check all that, and then we're going to come back. Okay, I have not addressed the cutting out transistors on this end yet, but where I am now is, while I was injecting that signal into the other side, like I said, I thought that capacitor was bad. It wasn't. Wiggling the capacitor was actually wiggling all the way down here to these pots, and they were just filthy. When these are in there, these are one of the hardest receivers to work on when it comes to the controls. Basically, you have this over top of the pots, and they're bolted on and screwed on. Then you have this cover that goes over this, and your dial pointer goes over this. Very, very difficult to get out without getting into a lot of, breaking things and so forth. And then you have to desolder the pot, because really the only way to really get in there and spray it is from the bottom, and it's attached like this behind all that metal. So I basically take the whole thing apart, unsolder the pot, take it out, clean it properly, resolder it, check everything, make sure it's good, put it all back together. So that's where we are right now. Once I get that part done, then I'm going to tackle those transistors. So just to give you a little idea of what it involves. It's not easy, and there are this many screws holding this little front cover on. So a lot of work, but it's worth it. This thing will last a lifetime after this. It'll be 30, 40 more years before you have to mess with it. Okay, just thought I'd show that. Okay, I went ahead and got it all together. Got all the knobs cleaned up, as you can see. Have the faceplate on here. tuner is out of whack. I mean, it tunes, but I'm not getting stereo multiplex, and the needle's off center, so it definitely needs an alignment. And for right here, you can see I replaced these two transistors right there. And now it is playing now. So I think we got all of our problems solved amplifier wise. And now oh, by the way, all the resistors and everything tested out good. So next thing now is to do the AM and FM alignment. So we'll get set up for that and we'll be back. Alright, so we're ready to start the adjustment, and if we go to the adjustment procedure, the first thing it starts with is the AM section, and they want us to take a 1K resistor and connect our signal generator to the AM antenna terminal and set for a 400 Hertz modulation, minus 100 dB, which is going to be almost nothing, and 30% modulation. Then we're going to connect our voltmeter, or our scope, how I have it. I have my scope connected to the tape record jacks, setting it to AM, and we're going 600 kilohertz on the dial and 600 kilohertz on the signal generator, and we're going to adjust T6. So that's where we are right now. And I'm going to go up. Right there. Okay. And of course, I have to shut off my Rigel arbitrary waveform signal generator. I want you to listen to something here. Do you hear that in the background? It does that. That sound is actually the circuit that makes this power on indicator pulsate when the signal generator is turned off. It actually interferes with AM radio. So whenever I'm doing an AM alignment, I actually have to physically unplug this thing from the power cord, or it will actually, just that pulsating light, which is unnecessary, will interfere with our AM signal. So I'll go ahead and unplug that, as long as I have the correct plug selected. Which, that's the next one. So I'm not sure which plug it is. It's not that one. Let's see. I'm going to have to unplug it from back here. Just listen to that sound. And as soon as I get this unplugged, that sound will magically go away. If you notice, the sound is gone. Okay, so for right now, we're going to adjust T6. And according to this, T6 is this coil right here, which ends up being this coil right here. Okay, so that's the one I'm going to adjust. And we're supposed to adjust for maximum amplitude. And what I'm going to do is I'm going to increase my amplitude so that we have something to dial in on a little more. Let me get my adjustment. And let's move up onto the scope. Get you situated here. And let's see what we can do. What I'm doing is I'm rocking the tuning capacitor, the tuning dial, back and forth across the 600 kilohertz, and then I'm peaking it with the coil at the same time. So right there sounds good. Okay. So now we're going to set it for 1400 kilohertz. So frequency, which is 1.4 megahertz. Keep everything the same, and we're going to adjust TC4. And if we come in here, TC4, come on, focus. TC4 is right there. So it's right on the tuning capacitor. Okay, so that's the second one over on the tuning capacitor. So let's adjust that. First we have to tune the dial to 1400. Okay, that's just right about on 1400. Right there. Okay. Okay, dial indication to point A. Indication to point A. And I do not see. Okay. So the next instruction here is telling us to set, let me get this to focus, to set the AM signal generator and SX450 to point A, which is up back here probably. They want you to go back. And adjust the bar antenna core for maximum indication. Okay. So now we're going to adjust our antenna core. Let's see, point A. And I am not seeing what they're talking about, point A. I'm just assuming they want us to set. Oh, I see. Point A. So back to 600. So 600 kilohertz. Back to 600 here. And let's get zoomed back in here. And we're going to adjust right down here. We're going to adjust. See if I can find it, the input of the bar antenna, you can see. So right inside there is a ferrite slug, and we're going to adjust that. Okay? So, come on, dial in. There. Okay. So, here we go. Can do. Well, it's stuck. Alright, let me get this unstuck. Alright, we're going to see if this gets any better. There it goes. Right there. Okay, here's what I had to do. And again, the instructions on this are not very good. Whenever you're adjusting the ferrite bar in the antenna, you can't just go through the antenna input jack. You want to loosely couple the generator to the antenna bar. So you're going in through here instead of through the external jack. I don't know why they don't say that in there. If you really adjust this with the signal going in there, it really makes very little difference. But this is how you want to do it. So we have that peaked out, and you can hear it was out a little bit. Not bad though. Okay, so let's go to our next instruction. And they want you to go return to point C. Okay. And we want to adjust TC5, which is this other one. So we're going to go back to our signal generator. We're going to go back to that. $1,400 kilohertz, and we're going to tune back to 1,400 kilohertz. Okay. And we're going to connect back to our little test point here, to our input. Just like that. And we're going to turn down the amplitude of the signal. Okay. And we're going to go down to TC5, which is this end one here, and we're going to adjust for amplitude. Hear it passing through the peak there? Right there. So right there is maximum. And that's all there is to it on the AM. So, okay, we're now on to the FM part of this alignment, and this is where it gets a little trickier. The AM's pretty easy. What I have is not the best setup in the world. I have a 75 ohm coax cable connected to a 300 ohm balun, which is going into the FM terminals. Now, they're asking for the signal generator to go into a 300 ohm dummy load and into the jack. So, you know, with 75 ohm coax and I have a 50 ohm terminated signal generator, the dBs are not going to be perfect. But we're really not worried a whole lot about that. We can kind of make some, just make some calculations for that to get around it. But really, what we need to do is we need to get the signal into the radio and get our frequencies lined up, and then the amplitudes. Really, the ones that have centering meters and signal strength meters and all these things where you want a meter deflection to equal a certain dB level, then your dBs are more important. But in this little tuner on this little radio, I think we can work with our little setup as it is. And plus, it really isn't going to change it that much, but it will make some little bit of difference. So anyhow, we're going to set up a very similar situation, except now we're going to FM modulate our signal at 400 hertz. Same thing, 100 dB, negative 100 dB, and 100% modulation. And this, again, this doesn't match my signal generator. I'm going to be at a negative dBm, and it's probably going to be somewhere around negative 60, negative 70 when you start out on this. I do think this FM section's out a little bit, so we're going to have some adjustments here. Again, tape record jack, that's all the same, none of that changes. And we're going to shut the muting, FM muting, off. We're going to go to FM. And we're going to start out at 90 megahertz. So let's set the signal generator. Okay, so we're going to go AM modulation, or FM modulation. Okay. And we're going to modulate. They actually want us to modulate this at 100%. So we're going to crank that all the way up. All right. And okay. All right. Okay. And 400 hertz and 90 megahertz. So we're going to go frequency 90 megahertz, and we're going to do our output. I'm going to start at about -70, and we're going to take this down somewhere around 90. Okay, which is pretty good. You can hear it there. Actually, -70 is really strong. So we're going to move our amplitude. I'm at -90. There's -100, and you can actually still hear it on this one. Okay. 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 All right. So, if we look up here at our scope, I got a nice noisy signal on there with lots of static. Okay. And we're going to adjust T3 for maximum deflection or maximum amplitude. So T3 on this is right here, if you look. Okay, right here, T3. It's inside this little can down here. And you can see it right down in there is going to be T3. So we have T3 and T4 and TC3. Okay. So T3, T4, and TC3. So T3 is a slug, and we're going to need the proper tool for that, which should be this little blue one here, I would think. Let's see. Yep, it's the blue one. And I'm going to bring up my my amplitude of my signal just a little bit. That's too much. I'm going to go -95. Okay, so amplitude -95 dBm. And that's just enough to get rid of some of the noise. Okay. And what we're going to do is when we go into our oscilloscope here, now as I tune this, you're going to see we're going to lose the symmetry of this as I go off frequency, off my center frequency. And the idea is to get it right at that null point where it's not crushing either side down. Now we're going to go to that slug that we have the tool in, and we're going to adjust it for maximum amplitude. Right about there. All right. So we're just setting this all up. So now the next thing, we're going to go to T5 for center scale indication of the meter. So now we're going to adjust our meter for center scale. Okay. All right. Okay. So adjust the meter, which is T5, and that's going to be this can right here. Okay, we're going to adjust that to make the meter centered. Okay, I'm going to have to do that off camera a little bit because I can't, you know, without, but basically we're just centering that needle in the middle. It's a little bit off right now, it's to the right. That's about as close as we can get it. Alright, let's turn that down. Alright, so the next thing we want to do, okay, is we're going to adjust FM signal generator for 9 dB output and adjust T1 and T2 for maximum indication. Okay, so T1 and T2, see if this will focus. Once again, these are the two adjustments on the tuning capacitor. Okay, so T1 and T2. Actually, they're not. They're little slugs also. So these slugs are down behind the tuner. You could see the one here. There's one here. The other one's behind this little tuning wheel right here. And they're both slugs. So once again, we're going to go, I'm just going to leave it where it is. And we're going to go T1 and T2 in that order. Okay. Let's get this back up here so we can see what's going on. Right there. See how that's cleaning up a little bit, taking some of that noise off of there. That's pretty solid now. just have a tiny little bit of noise up at the top. Okay. Alright. Set FM signal generator to 106 megahertz. Alright. And adjust TC3, then TC1 and 2 again for maximum indication. So TC3 is that little screwdriver adjustment trimmer that's next to those two slugs in that metal can. So that's the one right down in here. So let's get on that and see what we can do. 106. Okay. And we got to go down a little bit more. Amplitude minus 100 dBm. Okay. So we got a wee little bit there. You can see we're tuned right on it. And now we're going to adjust for maximum amplitude. Alright, now these are typically very touchy. You just barely move it and you lose everything. And you can see that one's right on. We don't even want to touch it. Either way I go, it crushes it down. So that one's good. And then they want us to do the TC1 and TC2 again. Okay, so we're going to, or T1 and T2, I'm sorry. And they're still peaked pretty good. We're not going to have to do a whole lot with those. Okay, looks good. And we're at negative 100 dBm, and I'm still picking up very little noise. Okay. Now, repeat steps 8 through 11 to eliminate variations in sensitivity at points A and C. Adjust T4 for maximum sensitivity. So, T4, again, is inside that metal can, and it's this one right here. So we're going to adjust that. Isn't this exciting? It's like watching paint peel, huh, guys? Alright. And that one was spot on, I think, as well. Yep. Spot on. So we don't have to touch that. Okay. Now, detune to noise only and adjust T5 lower core. Alright. For center of scale. Okay, so let's get on. There's noise. And it is way off center scale, so we're going to adjust lower core. Okay, we got that centered. And then we're going to come back up. Okay. We're going to adjust that. Okay. Alright, so our meter is now centered all the way around. Off by a little hair. Let me touch it back up. Okay. All right. Okay. Now, we're pretty much done with all that. Now we get into the fun part, which is multiplex. And I have never had the stereo indicator come on this. So either A, we have a problem, or B, something is really out of alignment. So let me go get the multiplex generator tied in and we'll go from there. Okay, move this up a little bit. Okay, and I should have my stereo indicator on, but I do not. So now what we need to check is if the light bulb's burned out for the stereo indicator. So I'm going to check that and I'll be back. Okay, so what it's wanting now is us to set up a Lissajous pattern like this using this scope setup here. I do not have this type of hardware, so what I'm doing is I'm using my multiplex output with my SG165 stereo analyzer, which is right over here. You can see it. Okay, and I'm feeding it via that cable into my HP FM modulated signal generator, and right now I have that set up, and I have both sides right now set up for 400 cycles. And basically, when I first started, after I hooked this all up and got it to work, what would happen was I can turn on the right and left modulation separately. Okay, so right, left, and you can see that I'm actually creating a stereo signal. Okay, so it's dropping out, and basically the way that you're going to do this is with you have the VR1 potentiometer right here they're talking about, and then you have T4 again, and basically by adjusting those, which are down here, okay, so VR1 is right here and T4 is back here again, you're going to adjust it so that when you turn right and left on and off, they separate. Originally when I started, it wasn't separating. Now I'm still not getting an indicator light, and I'm not really sure why I'm not getting an indicator light, but again, I've only traced one wire of the light bulb. I don't know if the light bulb references to ground or references if it's an active low or an active high, but I'm going to check that here. But everything is working properly now. I am getting stereo separation. As you can see, if I only modulate the right, if I only modulate the left, you can see I'm getting stereo now. And if I go to mono, it still does it a little bit, but not as much. And of course the mono switch doesn't have anything to do with it because I'm feeding the signal directly into the multiplex input right there for the test jack. So it bypasses all that. So clear as mud, isn't it? But don't mean to confuse you, but basically the way multiplex works is you have this 67.5 kilohertz and you have a 7.5 kilohertz pilot. Okay, so the 67.5 is your deviation, okay, and your 7.5 kilohertz is the pilot, and when it sees that it adds and subtracts the differences of those, it actually splits those up into your two channels from a single signal. Okay, so depending on how you modulate above or below the 7.5 above and 7.5 below the 67.5, you're picking up your right and left channels, and this circuit, multiplex circuit, actually is what demultiplexes it. So the name of the game is to get everything centered, okay, to get those frequencies all centered, okay. And so basically if you have your entire tuner set up mono, you know, all your IFs, all of your RFs, everything is properly aligned, the multiplex circuit, at least on these, is all handled by integrated circuit, so you really only have a couple of voltage levels and one frequency adjustment to get everything to line up. It's actually pretty simple. The trick is getting these signals into the tuner in a predictable manner so that you can do that. So everybody will do it a little different. It depends on the test equipment that you have. If you have an old scope that has XY mode, and you can go into XY mode and connect it into an actual stereo multiplex signal generator, that's, you know, the way they did it at Pioneer, you can follow these instructions and you will be able to see that square Lissajous pattern on the scope, and you can actually adjust it. But when you don't have all the right equipment, you got to kind of make your own procedure up. But it is working now, and we did get it to track right and left, as we could see. So now let's connect up to a regular antenna and see what happens. Okay, I reconnected my meter. That is an active low circuit, and when I did, if you look at my voltmeter now, when I get onto a stereo signal, I get an indicator on. When I go off, the indicator goes off. So, as we can see, our bulb is burned out, and that's all that's wrong with that. So, we'll take care of that here in a little bit. So let's check the tuner out. Let's shut off the signal generator and hook up an antenna and see what we can get. Okay, let's go through and see what we get. And there, I just kicked in on stereo. I'm getting really good stereo separation now. Again, I'm on a hill. I'm at the bottom of a hill, and I'm in my basement. And my antenna is not much better. So, as you can see, the tuner's working really well now. So, I'm going to go ahead and fit this with some LEDs, and then we should be ready to assemble this thing. And I think we're going to call it done. Okay, I'm not sure if you'd be interested in this or not, but just want to go over with you how I calculated the dropping resistor for the LED that we're going to put in our stereo indicator light. So basically, when this thing's active, there's 13.5 volts between the two wires that would be going on that little incandescent bulb. And we know that we want our LED to be running between 3 and 3.5 volts. And we want to have about 12 milliamps. Okay, this thing's good for up to 20 or 30 milliamps. But I would like to just see about, like I said, 12 mA. So that's going to be running nice and cool. And if we have 13.5 volts and we want 3.5 across here, we want 10 volts to be dropped across the resistor. So we're just going to use some basic Ohm's law. So resistance equals the voltage divided by the current. So if we know we have 10 volts we're going to drop across this resistor, and we have 12 mA that we want going through there, 12 milliamps. If we divide the 10 divided by 0.012, we get 833 ohms. Okay, and I dug through my resistors and I found this old carbon composition resistor, and it's 820 ohms, which should be close enough. So we're going to put that in, and that ought to give us our circuit for our stereo on indicator light. Okay, so that's how you calculate that anyways. Just thought you might be interested in that. Okay, I have the LEDs fitted in here, and you can see they're pretty bright, and I went with the warm white ones, and I replaced the LEDs in here, so the whole thing is LED converted now instead of these kind of burned up bulbs that were in there. So I think we're ready to put the cover on and take a final look at it. And there it is in all its beauty, all put together. Got it all cleaned up. Didn't turn out too bad. You can see. The face looks pretty good.
Ask this question and I guess open up a can of worms.
Got the stereo indicator working. We can find a stereo station. Right there. Okay. And I'll leave with this. Alright, till next time. Thanks for being with me on this one, and if you liked it, give us a thumbs up. As always, have a great day, and thanks for watching.